Hi, welcome everybody. Today's lesson is on significant figures, counting them in particular. We've already talked about that numbers in science have two meanings, the quantity, how big they are, and the place of uncertainty. So maybe in math 17 equals 17.0, but not in science. In science, 17 indicates that there is a plus or minus range somewhere in the ones place. So the range could be possibly from 16 to 18. 17.0 plus or minus 0.1 indicates a range of 16.9 to 17.1, a much smaller range. So when we read an instrument, we always read to the same place as an uncertainty. So basically we read all the certain digits, and we also include one estimated or one uncertain digit. So let's take a look at this ruler down here and this red line. Let's say we're measuring the red line. I'm certain that it's 3 something, but 3 what? So now I'm going to estimate between the 3 and the 4, and I'm going to say that's a little over halfway, so I'm going to estimate 3.6 centimeters, one certain number and one uncertain number. The plus or minus place is taken to be the smallest increment, which here is 1 centimeter, divided by 10, so this ruler reads to the plus or minus 1 centimeter. If it's plus or minus 0.1 centimeter, then we read it to the tens place. So I need to read this value, even if it was right on 3 exactly, I'd have to read it as 3.0. So I must read it to the tens place to tell the scientific community that the ruler reads to the tenths place. If I have a different ruler or a different device and it says plus or minus 100, then I would read to the hundreds place. We also know that we're not supposed to write too many or too few digits. For example, if the measurement really is plus or minus a tenth, like that last ruler, we don't write 12 plus or minus 0.1 or 12.02 plus or minus 0.1. One is too few and one is too many digits. We could read something like 12.1 or 12.0 or 12.2, something in the tenths place. If I had an instrument that read something like plus or minus 100, I wouldn't record a reading of 373 or even 370. I'd have to have something that was plus or minus in the hundreds place. So 400 plus or minus 100. And I don't know if you catch the little image right there. That's the Goldilocks and the 3 bears. So we just have to get it just right. Not too many, not too few, not too hot, not too cold. So what are significant figures? Significant figures are all the certain digits plus one uncertain digit. We always read it to the plus or minus place. Now we're going to count significant figures. How do I count them? And we'll talk about later why we want to count them, but first let's learn how to count significant figures. So when we count them, we start counting left to right with the first non-zero number, and we're going to stop counting them at the place of uncertainty, at the plus or minus place, but we include that number. So why do we start with the first non-zero number? Well, let's take a look at a picture of this balance right here. Right now, I have nothing on the balance. It reads 0.000. And you might think, wow, that's a lot of digits. Maybe that has 4 significant figures. No, right now there is nothing on the balance. There are no significant figures. There's nothing there. So if I add a small speck and the balance changes to 0.0006, that 6 is the first significant figure on that balance. So we always start with the first non-zero number. Then we count to the place of uncertainty. So you need to know where the place of uncertainty is. So let's look at this. How do we find the place of uncertainty of these numbers written here? So pause and give it a try yourself, and then we'll come back and see if you got them right. Welcome back. Did you get it right? Where is the place of uncertainty? 12.03, if it's written correctly, means the place of uncertainty is in the hundredths place, right here at the 3. How do I know that? because if it was at the tenths place, they wouldn't have written the 3 there. And if it was at the thousandth place, they would have added an extra 0. So this must be the plus or minus place. What about 6.000 grams? Here, once again, it's at this thousandth place, this last digit. What about this value, 0.0051? Where's the plus or minus place? Right here where this 1 is. But what about that last number, 38,000 liters? Where is the plus or minus? This one is the tricky one. It could be 38,000 liters plus or minus 1,000 liters. Or it could have been 38,000 plus or minus 100. Or 38,000 plus or minus 10. Or 38,000 plus or minus 1. I don't know where the plus or minus place is. If you personally are the one who measured the 38,000, you know where the plus or minus place is, and you can put that down. You would know if it was plus or minus 100 or plus or minus 1,000 or plus or minus 10. But if you did not measure it and they give you no additional information, no one says plus or minus anything, then now we have to assume the worst case. And the worst case here is the thousandths. It could be possibly plus or minus something in the thousandths place. Being uncertain about uncertainty, kind of like that, only happens when you have these big numbers that are multiples of 10 without any decimal place. So that's the only time that there is trouble with uncertainty. So now it's your turn. What place is the plus or minus value in for each of the following numbers? Go ahead and pause the video and see if you get it right. All right, did you get it right? The plus or minus place is here where the 4 is, which is the hundredths place. The plus or minus place here could be the tens, or it could be the ones. This is one of those multiple of 10 numbers, and I don't know, so I have to assume the worst. So this is the tens place. This is at the 0 here. This is the thousandths place. And here it's at the ones place. Did you get them right? Hope you did. Now, let's go ahead and count them. We know where to start, and we know where to stop. We're going to start at the first non-zero number, reading left to right, and we're going to stop where that plus or minus place is. So I have circled here the plus or minus place for these, and remember this last one, we don't know where the plus or minus place is unless they tell us, so we're going to assume it's here at the 8, unless somebody tells us differently. So go ahead and pause and see if you can count them. Well, did you get those right? Starting from left to right, 1, 2, 3, 4, 4 significant figures. Starting left to right, 1, 2, 3, 4 significant figures. Starting left to right, 1, 2 significant figures. Starting left to right, 1, 2, because I don't know exactly where the plus or minus place is, so I have to assume it's right here. So it has 2 significant figures. So here we don't count those zeros at the end without a decimal because we're not sure if they're significant or not. So a quick little review, you count left to right, you start with the first non-zero number and you stop at the plus or minus place. For most numbers, the plus or minus place is the last digit on your right. However, if it's one of these multiples of 10, you don't count those zeros at the end without a decimal. So if you know where to start and you know where the plus or minus place is, you know where to stop, it's really easy to count them. So now it's your turn. How many significant figures in the following numbers? Pause the video and see if you get it correct. Did you get them right? There are 3 significant figures here, starting left to right, 1, 2, 3. 4 significant figures here, 1, 2, 3, 4. Uh-oh, this is one of those multiples of 10 without a decimal. This 3 then probably is the plus or minus place, so I count 1, 2, 3. Here, left to right, 1, 2 significant figures. So what if we do want to make that 38,000 liters not as uncertain about its uncertainty? Let's say I want to be more specific and tell the reader where the plus or minus place is. In that case, you can turn these multiples of 10 into scientific notation. and add zeros if you want to show them that those numbers are significant. So if I write this number as 3.80 times 10 to the fourth liters, I am telling the reader there are 3 significant figures. Note, I do not worry about this 10 to the fourth. I'm not going to count that, just the numbers in front. So this is a way to write this number to tell the reader there are 3 significant figures. If I want to tell them there's 4 significant figures in this number, I would add another 0, 3.800 times 10 to the fourth. If I want to say there's 5 significant figures, there's one other way I can do it, and that's add a decimal point. That is telling the reader that there's plus or minus in the ones place. And so there is 5 significant figures if I write it 38000 decimal. It's your turn again. How many significant figures in the following numbers? Go ahead, pause the video, see if you can get it right. Did you get them right? Starting left to right and stopping at the plus or minus place. 1, 2, 3, 4. I ignore this part. 4 significant figures. Uh-oh, multiple of 10 without a decimal. 1, 2 significant figures. Here it's got a decimal. 1, 2, 3, 4 significant figures. And here, counting left to right, 1, 2, 3 significant figures. All right, hopefully now you're an expert at counting significant figures. If not, we'll practice some more in class. So why do we count them? Well, that's for another video. It's kind of like a cliffhanger today. So we'll see you in class. Thanks for listening.